Okay, good morning or good afternoon. We're here with period 6. You want to say hi? Hi. Period 6. Okay, we're going to be going over stoichiometry test review, questions 1 through 2 right now. So on the stoichiometry paper, it's this one right here. We've modified this. And I think I had you for questions 5. I asked you to cross off here. So we've already done that, but just want to make sure. When we balanced this out, we needed to have a coefficient of 2 here, which meant we needed a coefficient of 2 hydrogen gases, and then that'll give us a coefficient of 1 oxygen. So we've already done that in class. So question number 1, it's asking you how many liters of oxygen are required to react completely with 4.2 liters of hydrogen. So what I'd recommend is get out your handy-dandy conversion roadmap. And on this one, I got to kind of clean this up from previous problems. Actually, I think this one may be already set up. We are given in this problem 4.2 liters of hydrogen. So I'm going to call this side of my equation, molecule A is going to be hydrogen. And we're given 4.2 liters, 4.2 liters of hydrogen. So that's where I'm going to start in this. And we're asked to calculate how many liters of oxygen. So molecule B is going to be liters of oxygen. Is that in focus or is it out of focus?
It's kind of fuzzy.
Does it need to hit the autofocus? That can help a little bit. A little better?
Yeah.
Okay? All right. So now we're looking for liters of oxygen. Now, did I set this up right? I didn't make a mistake. We're starting here and we're ending here. Does that make sense? Okay, so we're going to have a 1, 2, 3-step conversion process for this. Oh, I probably better get a piece of scratch paper so that, because there's not much room on that sheet, is there? So let me put this under there so we have a little more room to work. So for problem 1, what's given? 4.2 liters of H2. Is that correct?
Yeah.
Can I zoom this in a little bit? Does that help? Okay. That's the first step. So we're over here at volume. We need to convert it to the mole. And when we convert to mole, we're going to be dividing by 22.4 liters, which should make sense because we want to get rid of this liter. 22.4 liters of H2 is 1 mole of H2. Okay. That'll be our first conversion. Now we're working on converting from moles of hydrogen to moles of oxygen. The molar ratio we need is going to be the moles of oxygen, which in this problem, how many moles of oxygen do we have? No, we don't have 2 moles of oxygen. We have 1 mole of O2 on here. So you got to be careful. This 2 is telling you it's a diatomic molecule, and we just have 1 of those. So it's just 1 mole of O2. And then we're leaving hydrogen. How many moles of hydrogen do we have in the balanced equation?
2.
We have 2 because when you're looking for these molar ratios, we're looking at the coefficients. Okay, that was my reminder to post attendance. It's posted. So we had, did we say 2 moles of H2? Is that correct? We've got our right molar ratio here?
Yes.
Okay, and so now we've, at this point in the conversion process, we are over here at moles of B. Now we need to get up here to volume because we're looking for volume. And my details are over here. If we're going from moles to volume, we're multiplying by 22.4 liters per mole, which should make sense because we want to get rid of moles over here. So 1 mole of O2 is 22.4 liters of O2. So let's start canceling out because this is the fun part now, okay? So let's see. We'll start over here. Liters of H2, liters of H2. Ooh, I'm going to use a green now, okay? Moles of H2 with moles of H2. Can you see that? Am I going too fast?
No.
You're okay? Right, you guys in the back, you paying attention? Or are you like, okay, good. You're not punching each other or anything like that? It's not period 4, okay. Moles of O2 cancels with moles of O2. And we're left with liters of O2. That's what we're looking for. Good. So now, let's see if we can do some canceling here. 22.4 can cancel with this 22.4, correct?
Yeah.
Making that 1 time goes in there 1 time. And then let's see, I've got 2 in the, over here, we got 4.2. We can cancel these out, can't we? Make it a little bit easier. 2 goes into 2 1 time. How many times does 2 go into 4.2?
2.1.
2.1 times. So now, after getting this all set up, our equation is going to be 2.1 times 1 times 1 times 1 equals, that just is 2.1, right?
Yeah.
And then 1 times 1 times 1, okay. Is that the answer, 2.1?
No.
No, 2.1.
Liters of
Liters of O2. Liters of O2. Okay, any math mistakes there? Are we good? Does that make sense? Did you get that? Give me a thumbs up if you calculated that, those who did it. Okay, so either we're all wrong or we did it right. Hold on. Okay, let's work now on number 2. Turn this around this way. Let's read through. Do I need to zoom out a little bit here to see the problem? You've got it in front of you if you're looking at it. How many moles of hydrogen are required to react completely with 3.1 moles of oxygen to form water? Okay, don't let to form water throw you. We're just given 3.1 moles. Now let's take a look at our roadmap. See, we're working with hydrogen and oxygen still. So I still have this set up for oxygen over here and hydrogen. I'm just going to leave it because I was using it like that in the previous problem. What's given? Oh, so let's do our givens on the chart here. We're given 3.1 moles of oxygen. So right over here, going to erase the old, get rid of that so I'm not distracted. We have 3.1 moles of O2. And what are we looking for?
Moles of hydrogen.
Moles of hydrogen. Oh, this is going to be easy because look at, we just have one conversion step, don't we?
Yeah.
Looking at the roadmap, that's why I really want you to use the roadmap. It lets you know you've only got one conversion to do. And since we're going 2 moles of A, we're going to put the moles of A, which in this case is moles of hydrogen, so over moles of oxygen. So let's get it set up. What was given in the problem?
3.1 moles of oxygen.
3.1 moles of oxygen. Okay, cool. O2. You know, I'm going to use a pencil because I'm pretty sure how to do this, but always use a pencil. Now we need to do the molar ratio. Is that correct? The mole to mole ratio. So we're coming over here to moles of H2. In our balanced equation, how many moles of H2 do we have? Do you look to the subscript or do you look to the coefficient?
2. It's the in front.
Well, answer my question. Do we find out the moles at the coefficient or the subscript?
Coefficient.
The coefficient. Okay, we want to make sure. We want that on the top because that's what we're going to. 2 moles of H2 for every, and we're coming from oxygen. We had 1 mole of oxygen.
Yeah.
Okay, for 1 mole of oxygen. Now this looks right because I want to get rid of oxygen here. Okay, now I'll use a colored pencil. Okay. Oh, there we go. Oh. Okay, so we're canceling out moles of O2 with moles of O2. And what's 3.1 times 2?
6.2.
6.2. Pretty. Okay, good. Excellent. You should be in algebra too. Okay. Joandre, you okay over there? Okay, use the careful fingers there, okay? Thanks, man. Okay, so 6.2 what? Is that the answer?
No.
What is it? Moles
Of H2.
of H2. Did we answer the question? How many moles of hydrogen? Okay, we started here. We should have done it right. Okay. So with that, do we want to do one more or do we want to call it a day?
Call it today.
It's 4 minutes until the end of the period. Well done, everybody. See you later. Goodbye.
Bye.